Hello once again. We're coming to you from the downtown core, near our offices here. And today's topic is experimental design. Let's begin. This is presentation 1.4. We want to acknowledge the development team of Brad, Spencer, and Amanda. In statistics, we have the notion of an observational study. As you can see on the screen here, the participants observe and measure, but do not interfere. And there are three types of observational studies. A retrospective study refers to the past. It's also called case control. Participants go back in time and collect the data. There's also the cross-sectional study, which takes place at one point in time. And finally, the prospective study involved in the future, also called longitudinal cohort. And we have here, maybe pause the screen and try to answer this. This type of study we call a retrospective study, primarily because the notion is in the past. And Nielsen's company, whatever. Today these meters will be used. This would be a cross-sectional study. And physicians at Mount Sinai wish to observe in the future, and this is called a prospective study. Now, an experiment is one in which the individuals, the experimenters, actually manipulate subjects or groups in some way in a critical manner. And there's several types of designs. The complete randomized design, where a random sample is selected from the population, much as you see here, and we're looking at maybe some degree of acute headache. We take a random sample of people from the population of all people with headache, and we flip a coin and assign them, each one, to either heads or tails aspirin or the placebo, which is a benign pill, which we'll talk about later. And the problem is, with this type of design, that multi-factors may come into play, such as gender, genetics, or whatever. The second type we want to study is called the randomized block design, and this involves a process whereby we take a sample of subjects and divide them into two homogeneous groups, maybe like gender, male, female. See coming on the screen here. And we create two blocks, one for males, one for females, and we randomly assign the placebo and the aspirin to the males and correspondingly to the females. And so by doing so, we remove gender as a potential variable, random variable, which may affect the results. And it provides a better focus due to the different treatments. Now, placebo control. Placebo is a fake pill or ineffectual pill. It's designed to hide from the participants whether they've received the real pill or the fake pill. And sometimes there's a perceived improvement in conditions because people who think they've got the real pill, and this is called the placebo effect. It should be acknowledged that the placebo effect can be responsible for upwards of 27% of the success rate of a prescribed medication. It's suggested that this is not ethical in some regions. And the blinded experiment is one in which the participants do not know which pill they've received, and this is to eliminate bias on their part. And a double-blind experiment is one in which the experimenters themselves don't know who received what pill. And this, of course, is to eliminate bias on the part of the experimenters in assigning the pills to the participants involved. Confounding refers to the notion that some factors may unknowingly have affected the results of the experiment. They're called often hidden or lurking variables, and they're extraneous variables which are involved as a factor. And if we're suggesting here that if you involve an experiment with human health, it's important to control for various confounding variables such as food additives, weed control sprays, and so on. So we ask you to look at Wikipedia site or the StatTrack site where this information can be found. And that's the end of presentation 1.4. We ask you to review this once again. Take notes as required. And when you're finished, go to presentation 1.5.